this other presentation by Alper Yagin. He's the CEO of the LoRa Alliance. He's joining us online today. He will be presenting the LoRaWAN Alliance and also the activities behind the LoRaWAN Association. So happy to have you on board here, Alper. Can you hear us?
Yes, very well. Thank you very much.
Excellent. So I will leave the floor to you, Alper. And if you have also a presentation, feel free also to just share it on the, you can share it on the Zoom platform if you can do that.
Sure. Now I'm sharing. I hope everyone is able to see. All right. Excellent. Okay, hello again. Thank you very much for this invitation. I'm sorry that I'm not there in person, but I'm very happy to be presenting the LoRaWAN technology and LoRa Alliance to this community. As your community is taking advantage of the power of water, we have been doing so with the power of the radio waves. And hopefully with this presentation, we will have thoughts about how we can further accelerate leveraging the power of LoRaWAN technology for the water networks. So LoRaWAN is a wireless communication technology that is specifically built for the Internet of Things use cases. And it has a very unique set of features. On one side, it provides a very long range of communication. The distance between the end device and the what we call LoRaWAN gateway, which is our base station, can be as far as 600 kilometers in case of line of sight. And that's where we are able to put LoRaWAN base stations on the low Earth orbiting satellites. And obviously that is one way of using LoRaWAN, but we also use LoRaWAN terrestrially by having base stations both indoor and outdoor. And the range can go down to a couple of kilometers. And that is the case when it's operating in dense urban. So as you can see, it's well above what one can get with Wi-Fi, Bluetooth, Zigbee, Z-Wave. And at the same time, it's a low-power communication technology. The transmission power is capped at 25 milliwatt. As such, it's very easy to build sensors that can last for more than 5 years and even 10 years. And it is very low cost to build LoRaWAN networks using low-cost base stations, which are converging towards Wi-Fi access point price points. And we are using unlicensed band in Europe, 868 megahertz, in US, 950 megahertz. And building LoRaWAN networks is as easy as building Wi-Fi networks, especially when it comes to any considerations to using licenses. And this standard is coming from LoRa Alliance, the global nonprofit technology association, whose mission is to build the technology and promote its adoption. And our technology is also published as an ITU recommendation, so it's an ITU publication as well. And behind that, we have the alliance with more than 350 members, spanning all regions and all verticals. And thanks to this technology being low cost and using unlicensed band, we are seeing widespread deployments, all the way from smart home use cases, people building LoRaWAN networks at home, to covering commercial buildings, to covering campuses, citywide, and we do have several nationwide networks, like in France, Orange provides a nationwide network, in Netherlands, KPN does that, and in Switzerland, Swisscom provides a nationwide network. And on top of that, we do have satellite providers, 2 low Earth orbiting and 1 geo satellite provider providing coverage. And the geo network is provided by EchoStar Mobile that provides pan-European coverage using LoRaWAN. And again, due to the openness of the technology and the low-cost nature and using unlicensed band, we see 3 distinct types of networks being deployed. One is the public networks providing connectivity. These are the several GSM operators leveraging LoRaWAN for providing public networks. And then private networks. These are much like the Wi-Fi networks where an enterprise built its own network for its own use, not sharing the connectivity with the others. And we also have community networks built by people for the people. And we also have the ability to integrate all these 3 distinct types of networks through roaming integration. And this variety, there is no other wireless data communication technology that can provide this much variety. And this is driven by not only the innovation we have with the technology, but also the innovation we have in the business models. And just to give you a handful of examples, the wide span success stories, deployments of LoRaWAN. Smart cities is one of the verticals we serve. The Zener has deployed 600 gateways in the city of Hamburg to provide nearly 100% outdoor coverage, connecting EV charging stations, parking sensors, smart metering in schools and apartments. And the obvious benefit of such a network is cost savings, improved operational efficiency, and reduced environmental impact. And if we look at another example, Starbucks stores in North America, more than 10,000 Starbucks stores have deployed LoRaWAN base stations for cold chain monitoring. And through that, they have operational efficiency. Instead of having to do manual reading of the temperature sensors, now they can automatically read and process the data. And smart lighting, this example is from India and Middle East. Tata Communications deployed more than 300,000, almost 400,000 street lights, all connected to LoRaWAN network that is specifically built for the street lighting purpose. And now, just to give you a few examples about the water industry, we have several utilities that deployed LoRaWAN for remote metering. The largest deployment we have is with Veolia in France. They have over 3 million meters that are connected to the public LoRaWAN network operated by Orange. And Veolia has been historically using another communication technology called wireless M-Bus. With the invention of LoRaWAN around 10 years ago, they started evaluating this technology, and they have been migrating their wireless M-Bus connected meters to LoRaWAN as soon as the meter reaches the end of its life. And so reducing the water loss, optimizing operations, and increasing customer satisfaction are the obvious benefits of enabling metering, remote metering. And here, the long-range nature of LoRaWAN, which translates into being able to go through obstacles like walls and even metallic obstacles, that is what Veolia has been going after. And also the low power nature, which gives a very long lifetime for these meters, which typically needs to survive in a single battery charge for more than 10 years, sometimes 12 years, until they reach the end of their life without any recharge. So jumping from Europe to US, another AMI automatic metering infrastructure deployment is with Netmore in Tampa Bay metro area in Florida. Again, 80 tower-mounted gateways, those are the base stations, providing connectivity for 200,000 water meters. And another really important thing with LoRaWAN is LoRaWAN radio technology and the architecture and the networks are multi-purpose. Once they are built for one application like metering, they also get used for several other use cases like smart cities and gas metering, and also other needs of the public services and also private citizens as well. And one more example now, jumping to Australia, and Ananco, a member of LoRa Alliance again, they have been using LoRaWAN for monitoring the water pressure and flow in the water pipe. So that's an upstream element in the water delivery infrastructure. And they're using pressure sensors to detect any leakage and any theft. And that has been providing Ananco a way to accelerate response time before the water leaks and pipes bursts can occur. So we not only, our members not only leverage LoRaWAN for monitoring and remote control, but also for predictive maintenance as well. And LoRaWAN technology is multifaceted. It's not just for the businesses, but also used for the benefits of people and the planet as well. Today, it's used for search and rescue In France, there are panic buttons actively used in hospitals, at schools. Nearly 20 wildlife parks in Africa have deployed LoRaWAN in large scale to monitor the movement of the animals and also the assets and the park rangers. And wildlife detection is another, wildfire detection is another use case that has been deployed in the field. And if we look at the adoption in the market, we fall under the low power wide area networking arena, along with other technologies like Urban IoT, Sigfox, LTM. Today, the most number of devices are on the Urban IoT network, but 90% of those are in China, and even those are declining. And if we were to take those out, the largest population of LPWAN connected devices are with LoRaWAN. And today we have more than 100 million LoRaWAN devices in the field. And our largest networks, like the ones operated by Zener, Actility, and the Things Industries, they are seeing 50% CAGR growth in the device count year over year. And like I said, we are an alliance. We have members from all corners of the world, coming from chip makers, device makers, base station vendors, core network vendors, system integrators, operators, and alike. This is the collection that we have, and it's ever growing. We have a pretty good momentum. Hopefully, the audience in this room would find the strengths of LoRaWAN interesting and consider joining us, as we have been building the fourth pillar of the wireless data communication structure, complementing the functionalities provided by Bluetooth, Wi-Fi, and 5G, and also the upcoming 6G. And we've been doing heavy lifting here, covering the so-called massive IoT use cases. Here I leave my email address. You can contact me anytime, and also our membership page. Anyone interested, we're welcome to check it out. And if I have time, I will be very happy to answer any questions as well. Thank you for listening.
Thank you, Alper, for that insightful presentation. Maybe just quickly, if there are any questions for Alper, as he will need to run off after his presentation. So I will ask just very quickly if there is anyone that would like to ask a question. I think the case study with Veolia was quite an interesting one as well. And I think as well with regards to the importance of communication technologies, which is also a very key important part in terms of reducing the energy consumption of these smart devices. So I think the work that is being done in LoRaWAN Alliance is quite insightful. We have one question from Michael.
Yeah, very interesting presentation, Alper. Thank you. I'm just wondering, you've got other technologies there as well. Do you see these as collaborators or competitors? Because, for example, I work with a number of companies who do things like tracking of assets. And depending on where the asset is, there are different infrastructures available. So they're working very hard to come up with, sensing technologies that are compatible with multiple wireless communication protocols. So do you work with the other alternative technology developers to try and help people improve the interoperability between these systems?
Yeah, absolutely. Thank you very much. That's a really good question. With the majority of the wireless data communication technologies, we are very complementary. For example, when it comes to tracking, using Bluetooth like beacons is a very common practice. The Bluetooth beacons or the Bluetooth transceivers embedded on the LoRaWAN sensors for indoor geolocation. Similarly, using UWB for high precision geolocation. We also use Wi-Fi again with trackers with the Wi-Fi fingerprinting. So a lot of trackers in the field, when they're using LoRaWAN as their connectivity to the internet, they leverage these other technologies. Same thing with the NFC and RFID as well. we're about to publish a technical recommendation on how to transport GS1 identifiers over LoRaWAN, and that is our way of collaborating with the RFID and the NFC technology. We even have devices in the field that has multiple backhaul connectivity, LoRaWAN and cellular. At this point, we do not have global coverage of LoRaWAN, but wherever there's LoRaWAN coverage, the tracker leverages LoRaWAN for connectivity. Wherever it falls outside the LoRaWAN coverage, it falls back to using cellular. So those are the cases where we do marry several other wireless communication technologies with LoRaWAN. So majority of these are very, very cooperative.
That's great. Just one very quick comment. Have you ever considered maybe doing a white paper just to show people how to marry all these technologies together into an applications? I think that would be very useful to us in the community.
Absolutely, that's definitely a good tip. Good suggestion. I will take this into LoRa Alliance and we'll look into that. I appreciate that feedback.
That would be brilliant. Thank you very much.
Thank you.
Thank you, Alper. Thank you, Michael, for those questions. I think we're really running out of time, so we'll skip into the next panel discussion. But I'd like to give a round of applause again to Alper for his contributions, and thank you again for the insightful presentation.
Thank you very much. Have a great day.
Thank you.